Welcome. We're going to do something a little different in this explainer. We're not just going through physics content, we're actually going to get inside an examiner's head. How? By breaking down a real GCSE question, question 9, using the official mark scheme. The goal here is simple, to see exactly what it takes to lock down every single mark.
All right, here's our game plan. First, we're going to decode the mark scheme itself. What is it really telling us? Then, we'll dive into each part of question 9, finding a range, spotting the variables, nailing a big calculation, and then building a perfect explanation. And stick around because at the end, we'll pull it all together into a winning strategy you can use on any exam question.
So before we even touch the question, we've got to talk about our secret weapon for getting the best possible score, the official mark scheme. This thing is so much more than just an answer key. It's like having a window right into the examiner's mind. It teaches you to think like the person who's actually marking your paper.
And really, that's the million-dollar question, isn't it? You can know all the physics in the world, but if you don't know how to present it in the very specific way that gets awarded marks, you're leaving points on the table. This is all about mastering that second part.
Okay, so this document right here, the official mark scheme for this question, this is our blueprint. It tells us precisely what an examiner is trained to look for and what they're told to give marks for. And here's the best part. It's not a secret. It's a guide, and we're about to use it to our full advantage.
All right, let's put this into practice with the very first part of the question, 9.1. It's a pretty straightforward one marker just asking for a range. And here it is, the exact entry from the mark scheme. You've got the question number, the answer they want, and the mark. But you've got to pay attention to that extra information column. Trust me, that's where the hidden gems are often found. So the main correct answer is 0 to 12. Now, you see those little brackets around the point 0? That's just the mark scheme's way of saying you don't have to include the decimal. 0 to 12 is perfect. You get the mark. Easy, right? Well, hang on, because that's not the whole story. Now, this is where it gets really interesting. The mark scheme uses a magic word, allow. That word tells the examiner they must also accept 2 to 12 as the correct answer. Why would they do that? Well, maybe the graph or the data wasn't super clear at the beginning. The point is, they built in some flexibility. This is a huge insight. There isn't always just one single rigid answer.
Okay, let's keep going with the next part, 9.2. This one's all about experimental design, and it's asking you to name a control variable, something you'd keep the same to make it a fair test.
Now, if you look at the mark scheme for 9.2, you'll spot two possible answers right there in the answers column. But the most important thing on this line is that tiny little 3-letter word sitting right in the middle. So this is the first of two possible correct answers that would get you the full mark. A nice, clear, specific statement about what you have to keep constant during the experiment. And this just shows you the incredible power of the word or. The mark scheme is basically shouting at us, you don't need to write both. You could have written mass of gas, or you could have written temperature of the gas. Either one of those gets you the mark. It's a choice. All right, now for the big one, the 4-mark calculation. I know these can look a bit scary, but the mark scheme shows us that marks are given out for the process, not just for the final answer. Let's break it down step by step. Okay, let's walk through this. Your first mark comes just from calculating the constant. Boom, 1 mark in the back. The second mark, for correctly putting that value into the equation. Now, your third mark, and you would not believe how many people miss this, is for showing the rearrangement. Don't just do it in your calculator or in your head, write it down. And finally, the fourth mark is for the correct answer. You see, even if you totally mess up the final bit of math, you could still get 3 out of 4 marks just by showing your method. That's why this is so important. And would you look at that? There's our favorite word again, allow. The mark scheme says to accept 68, even though the exact answer is 67.5. This gives us a great look at how examiners think. They know you might round your answer, and as long as it's a sensible rounding, they're told to give you the mark. They're not trying to catch you out. Okay, final part. Let's break down the 3-mark theory question. For these longer answers, the mark scheme shows us that it's all about building a logical chain of reasoning. One point has to connect to the next. Let's build this explanation together, 1 mark at a time. The question is about what happens when the volume of gas gets bigger. So your first mark is for stating what's going on with the particles. Because they have more space to roam around, they're going to collide with the walls of the syringe less frequently. That's your first link in the chain. So what happens next? What's the consequence of that? Well, since the particles are hitting the walls less often, the total average force they exert on those walls goes down. It's a direct cause and effect. Fewer collisions leads to a lower force. That's your second mark, right there.
And to get that third and final mark, you just have to connect it all back to the definition of pressure. Since pressure is just force divided by area, and we've already established that the force has decreased, well, the pressure must also decrease. You've just built a perfect, logical story from start to finish. That's a 3-mark answer.
So after going super deep on just this one question, what's the big takeaway? What's the winning strategy that you can now apply to the entire exam paper?
It really all boils down to a few simple rules. First, hunt for those keywords like or and allow. They give you options. Second, for any calculation, show every single step of your working out. There are easy marks just sitting there for the taking. And third, for the written explanations, think like you're telling a story. Build a logical chain where every point connects to the next. If you can start doing this, you're not just answering questions anymore. You're playing the exam by the examiner's own rules.
By looking at mark schemes when you revise, you're not just learning the physics. You're learning the rules of the game. You're learning what examiners are actually trained to look for. And applying that knowledge, that's how you turn what you know into the marks you absolutely deserve.